This is the first of the 5 different types of chemical reactions. As I mentioned before, there's a number of different ways of classifying these, and the scheme that we will be using uses 5 different types of basic types of chemical reactions, and this covers an awful lot of chemical reactions. So we're going to be talking about synthesis reactions, decomposition reactions, single displacement, double displacement, and combustion reactions. In this section right here, in this video, we will be dealing with the first of these, the synthesis reactions. Synthesis reactions are also called composition reactions. Synthesize means to create. If you look up that word in the dictionary, or you think of what a synthesizer is, it's something that's used to create something. And so in a synthesis reaction, you have 2 elements, usually elements, they may be simple compounds, combining to form a single new compound. So we can represent that by the general equation A plus X yields AX. Now when we use this, this type of nomenclature, the letters A and B, and you do need to remember this, A and B refer to metal ions or atoms. X and Y will refer to non-metallic elements or ions. Now, what is a metallic ion? That would be something like sodium, iron, copper. It could also be something like the ammonium ion, which is a positively charged ion. Non-metallic ions can be, again, non-metals like chlorine, bromine, oxygen. So it could be those elements or ions. It could also include ions such as carbonate, nitrate, sulfate. Any of the negatively charged polyatomic ions can be considered non-metallic ions. And so as this says, A and X can be elements or compounds, and AX is a compound. So you have 2, the vast majority of the time these 2 will be elements. 2 elements yields a compound. So synthesis reaction, element plus element yields compound. One type of synthesis reaction is when elements are combined with oxygen to create an oxide. Almost all metals will react with oxygen, not every single one. And when we get to section 3 in chapter 8, we will look at some ways of determining whether or not which elements or which metals will react with oxygen. But the vast majority of them do. An example of this is given by this equation: magnesium plus oxygen. Notice we have 2 magnesium and O2. Remember, oxygen is one of your diatomic molecules, and so it always appears when it's by itself as O2. Yields 2 MgO. This was the reaction that you saw in the lab in chapter 7 when we burned the magnesium and we formed magnesium oxide. Okay, that was the reaction that occurred. Group 2 elements react in a similar manner to this, all forming elements with the compounds with the formula MO. All right, where you have 1 atom of the group 2 element and 1 atom of oxygen, and this is because all of your group 2 elements form ions with a charge of 2 plus, and of course your oxide is 2 minus, so that reduces to that. Group 1 elements will form oxides with the formula M2O because they have a charge of +1, oxygen is 2 minus, cross them down, and you get M2O for the group 1 elements. So an example of this, lithium oxide is formed with from lithium and oxygen, and it gives you the resulting oxide is Li2O. Group 1 and 2 elements will also react with sulfur, much in the same way as they react with oxygen. Sulfur is a little bit different because when it's by itself it is usually S8. It's in a large ring type structure, and so that gives you slightly bigger coefficients here when you balance these equations. But you see that rubidium forms Rb2s. Rubidium is group 1. Barium is group 2, and that forms a BaS. There are some nonmetals that can also react with oxygen to form oxides. Sulfur is one of those. It reacts to form sulfur dioxide according, again, to this equation. Again, you see the S8, so it takes 8 O2s to get SO2. Okay? That is a non-metal reacting with oxygen to form an oxide. Hydrogen will also do that. That forms the compound dihydrogen monoxide. So if you want to sound really smart at dinner tonight, ask your parents if they would pass the dihydrogen monoxide, and you're just asking them for a glass of water. This is the reaction for that, and that's exactly as you would expect it. But again, remember, hydrogen, it's over above the metals. It acts just like the group 1 metals. You'll notice this is like a group 1 metal oxide, but since hydrogen is not a metal, then we consider it slightly different. Most metals will also react with the halogens, the group 17 elements, to form either ionic or covalent compounds. Group 1 metals react to form compounds with the form MX, the group 1 metal, and one of the halogens. And you see, again, a common example. Sodium plus chlorine yields sodium chloride. Okay, and again, that is balanced. Chlorine is one of your diatomic molecules, as are all the other halides. Group 2 metals will form the MX2 compound. Magnesium plus fluorine forms magnesium fluoride, MgF2. Fluorine is so reactive that it combines with almost every single metal. There are very few that will not react with fluorine. Active metals are the highly reactive metals. These are the ones that tend to react. Oxides of active metals can react with water to produce metal hydroxides. This is one case where you have, and we'll look at this example, calcium oxide reacts with water to form calcium hydroxide. Here's a case where you do not have an element, you have a simple compound, calcium oxide, reacting with water, again, not an element, but a simple compound, H2O, to form calcium hydroxide. Here you see the equation for that. So you have simple compound plus simple compound forms a single compound. So the basis for synthesis reactions, even though we say it's usually element plus element, it can in some cases be slightly different, and you have a single compound being formed here, the calcium hydroxide. Oxides of some of the nonmetals, these are in the upper right portion of the periodic table, react with water to produce oxyacids. So if you take SO2, sulfur dioxide, and react it with water, or dissolve it in water, it forms H2SO3, which is sulfurous acid. Okay, that is an oxyacid. It's the sulfite and hydrogen, sulfite ion and hydrogen. Some metal oxides and nonmetal oxides will react with each other to form salts. Okay, so you see the case of CaO, calcium oxide plus sulfur dioxide creates or produces calcium sulfite, okay, CaSO3. And that's the last slide in our section in our video on synthesis reactions.